Happy New Year's and welcome back to Operating 15, a video podcast series sponsored by AVEVA, where we focus in on our user community by showcasing some tips and tricks, some cool features, and just general discussions about our technology. I'm your host, Edward Thongpanif, and as always, I have Mary Alice with me, joining as my co host for the series. And this time around, I think the conversation that we're going to be focusing on today is really another capability that's really popular in our user community called MQTT. Why don't we get started on the basics of what MQTT is all about? So, Mary Alice, if you don't mind walking us through the technology and just really some of the benefits there.
Yeah, absolutely. And again, Happy New Year, everyone. Welcome back to this podcast. Basically, MQTT, it's really a super lightweight messaging protocol that lets devices publish data to different topics. And then for anyone who's subscribed to those topics, they'll get the updates right away. MQTT is really built to be fast, it's built to be efficient. So even when you have tons of devices or you're working within a limited bandwidth, it can still be fast and efficient. And what I would say makes MQTT really stand out is it has a publish and subscribe model. So what this means is that instead of every device constantly pulling the system and asking, "Hey, do you have anything new for me? Hey, what's new?" It kind of flips that around because devices only send data when they actually have something to say. And then whoever subscribed to that just gets that information automatically. And this is really a huge benefit because it cuts down on so much wasted network traffic because you're not constantly flooding the system with constant check-ins asking for that new data. And so again, the network only moves that data when something meaningful has happened, which really just helps with improving performance, lowering bandwidth, and then allows for much easier scalability as well. Just one other, benefit I want to kind of highlight here is MQTT is really reliable. And the reason for this is because MQTT has different quality of service levels, which basically allows you to decide how important message delivery is. So maybe you want a message to be delivered exactly once, maybe delivered at least once, or just kind of at a best effort approach. You can choose what makes the most sense for your use case. So I know that was kind of a lot, and that just really touched on some of the benefits of MQTT. There is certainly a lot more than that, but that at least should give you a good introduction.
Certainly got a tongue twister going on with the MQTT, so hopefully we'll get going. But I really appreciate that, and thanks, Mary Alice. I think that gives us in the audience really a great introduction to what the technology is all about. But I hear a question from clients all the time about this idea or notion about a unified namespace or UNS. How does MQTT tie into a unified namespace, and can we use technologies like InTouch to be a part of that particular architecture?
Yeah, that's a great question. And maybe what I'll first do is kind of take a step back here and really just define what a unified namespace is. And really, UNS is just a way of saying you have one source of truth for all of your data. And it's really a single organized place where everything publishes information using the same naming structure and then updating in real time. Maybe an easy way to think of this is you could think of MQTT as the pipe, and then the UNS is the map of everything flowing through that pipe. So MQTT basically provides the transport layer, which is the way that the messages are moving around. And then the UNS gives the structure and the organization. So that way the entire enterprise knows where to find the data and then how it's being labeled.
Right. And so, I mean, I think about the old concepts of, a bunch of systems talking point to point. The unified namespace becomes sort of like a centralized location where data is exchanged through common structures or just different locations there.
Yeah, that's exactly right. So everything within a UNS setup, the machines, the lines, the plans, even the business systems, they publish data into one shared topic structure. And then MQTT fits that model really well because it's, again, scales easily. It doesn't rely on that constant polling. So each system can subscribe to the pieces of data that it cares about and then get those real-time updates instantly.
And so, I mean, just going back to our own technology internally at our space is what about InTouch? Like, I mean, the other question I think I asked a little bit earlier was, can technologies like InTouch participate in a unified namespace?
Yeah, absolutely. So I shared this architecture here, which kind of demonstrates that a little bit, where InTouch is able to subscribe to MQTT data. It can publish data back out, and then it can also connect to brokers that sit between the OT and the IT networks.
Okay, so I see it on this architecture slide here, and I
Mhm.
know that we had a lot of conversations up to this point, but I'm really curious on how the whole entire process works. I want to see it live in action. Can you show us how this is configured within the applications here?
Yeah, let's do it. So we do have a blog post on this topic that dives a little bit deeper into some of the things that I'm going to be showing here in the next couple minutes. But so before I get, too far into things, the first thing that I did was I installed MQTT Explorer just as a way to view the data that I'm going to be publishing from InTouch. So MQTT Explorer is just an MQTT client that allows me to view a structured overview of my MQTT topics. So really, I'm using this as a way to simulate communication between InTouch and then an MQTT broker that's running locally.
Okay, so in terms of a first logical step here, I think the things that we need to take a look at is setting up what we call the communication driver, right? And so I believe we have a driver set for that.
Yes, we do. So in the operations control management console, this is where we can set up our communication drivers for any protocol. Right here, we have our MQTT communication driver. And, at a minimum, what you need to do is enter in the address for the broker and then click to validate that address and port. And we can see that the connection to the host was successful. There's some additional parameters here, being able to encrypt connections, additional security, things like that you can set up if needed.
Okay.
And then within my InTouch application, the next thing that I need to do in order to make sure that I'm communicating with my MQTT communication driver is set up my access name. So, we can set up access names for regardless of whatever protocol we're communicating with, whether that be OPC/UA, in this case, we're doing MQTT. And when I set up an access name, there are really three key things that I need in order to set this up properly. I need the network name for where the driver is. I need the application name, which refers to the service that we're calling up. And then I also need the topic name, which is the scan group. So for MQTT, that refers to that quality of service, that QoS level for message delivery. Here we're using QoS 0, which means that the message will be delivered no more than one time.
Yeah, and this is all great from the configuration standpoint. It doesn't seem like there's a lot of steps. I can just set it up within my communication drivers directly to the broker itself. I can, assign my user security groups, certificates, whatever I want in there. And then
Mm-hmm.
basically from within InTouch, I just set up the access name to point to it. Can you show us how this actually functions in real life?
Yeah. So in my InTouch application here, what I did is I created this UDT to kind of demonstrate this. So we had a previous podcast on UDTs, and in case anyone missed that podcast, basically a UDT allows me to create an object-oriented hierarchy for my tags in InTouch. So if you compare UDTs to maybe like the traditional tag name dictionary, that tag name dictionary is really a flat tag structure. And so these UDTs allow me to have more of a hierarchy, as you can see here. And what's really nice about this, and by being able to create this hierarchy, I can actually make sure that my model here aligns with ISA 95 model standards. And so I kind of demonstrated that here where, in this example, I have my UDT where I have my enterprise, my plant, my line, my equipment, and then, the tags for my equipment here. And so now what this means is I create this model in InTouch that adheres to the ISA 95 standards. And then what I can do is publish my model to my MQTT broker as the topic hierarchy. So that way within my MQTT broker, I have I'm following those same ISA 95 standards. And really just the way that I do this is, for example, for my level tag here, I have my access name pointing to that MQTT access name I created earlier. And then I have my item name, which creates that topic hierarchy to align with the ISA 95 standards, which matches my UDT structure here.
So sorry, Mary Alice. Can you kind of elaborate on what is a topic in your definition there?
Yeah, so a topic is really just an information structure that messages are sent to in the MQTT protocol to route messages between the publisher and then the subscriber. And so these topic hierarchies can be created using a forward slash to generate sublevels in the hierarchy, and represent that nested path. So just kind of as an example, as you can see here, for my level tag, I have my enterprise slash Dallas slash line slash tank, then slash level. And so these slashes then create those sub levels within my MQTT. And so what I can actually do maybe to kind of demonstrate that here is I have this very simple faceplate. And then within my MQTT Explorer, I can actually drill down into those, different levels here all the way down to my tags.
Got it. And I see that you have, a level value, but it's also an alarm. Can you explain sort of what's going on here, just so we can sort of visualize what's happening?
Yeah, definitely. So again, I created these two tags, level, which is just, a very simple example of, a typical tag that you're going to be measuring maybe as a tank, for example. And then I also have this in alarm tag here. And the reason I created this is because I wanted to demonstrate that we're able to pull alarm information from InTouch to the MQTT broker as well. So, really the way that I did this is if I go back into InTouch here, for my level tag, I have this high alarm enabled, when it goes above 95. And then I created this application script that sets my, in alarm tag equal to my level dot alarm. So when my level is actually in alarm, it's going to, trigger that in alarm tag. And what's nice about this as well is these UDTs include dot fields that will expose additional parameters and properties of my UDTs. So if there are other things that you want to expose from your UDTs, you can do that. Things like, alarm comment, alarm message, certainly a lot of options here. So in this case, I'm just using that alarm dot field in order to expose that alarm information.
Yeah, this is interesting because you can actually create the UDT to mimic the structures that we have to push information from InTouch. So if I wanted to take something from tag name dictionary and publish it to a particular model, I could do that by shaping that data using the UDT, publishing that structure up to, let's say, my broker there, and then any tags from a tag name dictionary pass along that information there. I think that's really cool. Can you also do things like bidirectional communication? So if I have a message from my broker, can InTouch receive that information? Is it possible?
Yes, it can. So, in my MQTT Explorer here, what I can do is it's, let's say I want to update this level. I can publish this back, and now you can see within my InTouch application, that updated information. And, just going back to the alarm information as well. Now we're above that high alarm limit, and we can see that our in alarm tag has been updated as well.
Great. So regardless if it's just integers or booleans or discretes or whatever we're sending over, that
Hmm.
information gets translated back and forth. Same thing I would assume with messages as well, like strings and all that stuff there as well, right? So
Yes, yeah.
I'm just looking at the time, and fortunately, I think we reached the end of our 15-minute episode, and really, in theory, the end of this particular program. So, like always, if you'd like to get your ideas on our show, put or any of your thoughts for our next session, please post it to our forums at AVEVA Heroes HQ. You could also follow us on LinkedIn or Twitter at AVEVA to let us know about your technical needs. But really appreciate the time, and thank you again for all listening in.
Thanks.